Welcome back, and in this lesson we are going to learn about BioSwift arrays. And a BioSwift array is an ordered collection of DNA and or RNA nucleotides, nucleobases, or sequences used for biological computation written in pure Swift 4. So first what we want to do is create an array and allocate it to a variable. And for the value, we are going to use one of our data sets. So let's start out with the cancer nucleobase data set. I'll just have to type BioFastA. And the first one is D for diabetic. I don't want that one. We want the second one, which is the cancer. And if I do a count on that data set to see how many nucleobases is in that data set, so I'll say DNA dot count, then it shows me that there are 39 nucleobases. So next, let's use another data set and let's get the sequence, which is the gen file. So I'll say biogen, see, and that gives us the sequence file. And we'll do a count on that. And that shows 5 sequences in that array. Here's the first one, second, third, fourth, and fifth. So I want to store these as modules for later use. I am going to highlight, and I am going to call it BioSwift. Breast cancer nucleobases array. This time I'm going to put something in a summary. Array of breast cancer nucleobases. And for the shortcut, we'll use BioFastA, C for cancer, then we'll put array after. And done. And you'll see down here, now you have a breast cancer nucleobase array with a summary. And I want to do the same for the sequence. BioSwift breast cancer sequences array, and array of breast cancer sequences. Shortcut biogen C array. So we are building our BioSwift modules here. So let's do a little more hacking here. Let's go up to the Nucleobases. And I'm going to say, show me the first nucleobase and the last nucleobase. And to do that, let's say DNA dot first. And that shows us the thymine as being first. DNA dot last. That shows us the adenine as the last nucleobase in the array. Let's do the same thing for the sequences. DNA2 dot first. And that shows you the last sequence. DNA2 dot last. And that shows us this last sequence. So there's the last. And here is the first. Okay, so let's go back up to our nucleobases. And we have 39. Let's make it 40 nucleobases by adding a nucleobase to the front of the data set. So I'll say DNA dot insert and let's put adenine at the front. So we'll say and so now A is at the front at the 0 index. If I were to print it, you would see that adenine has been added to the front, and instead of 39, it should be now 40 nucleobases. And now you see 40. Let's hack the sequence the same way. So now instead of this being the first sequence, we see the sequence that we inserted is the first sequence. And instead of 5, we should now have 6 sequences. And as you can see, we have 6 sequences. So let's remove a nucleobase here. So this has a lot of T's. We have 1, 2, 3, 4, 5 thymines in front. Let's take one away. So I'll say instead of 5, don't forget we added the adenine. You would see 1, 2, 3, 4, 5. So here you would see, now there's 3. You have to know where to locate it in the console. Let's try that with a sequence. We'll see it better. So that is the sequence that was removed. That was actually at the 5th index. If you didn't feel like counting and you always wanted to just, if you had like 1,000 sequences and you wanted to remove the last one without counting, you would just say DNA to remove. I could say remove last actually. That would remove the last sequence. So now if I print, you see that is not the last sequence anymore. So now let's get a count on each individual nucleobase here. So I want to make some room because this looks kind of messy. So we want to get a count of each individual nucleobase in this FASTA file. So we'll set each nucleobase to 0 first, then we will run a for loop, and then we will print out the results. So there are 13 adenines, 5 cytosines, 7 guanines, and 14 thymines in this particular data set, with a total of 39 nucleobases altogether. So let's save this particular function for future use. So we know that these nucleobases are adenines, thymines, guanines, and cytosines. And if it were RNA, it would be uracils with the U. These are sequences, so they're different nucleobases in each sequence. We could allocate each sequence to a variable and then count those. But for right now, it's just be easier to count how many sequences, which we've already done. Next, we will go over hacking DNA with biosets. See you there.